I'm Paul Steen. I'm a faculty member in Chemical and Biomolecular Engineering, Professor Maxwell Upson Professor of Engineering in the college. My overall scientific expertise is in the stability of systems, and I'm particularly interested in those where surface tension is important somehow, the dominant role. So most of the devices we use, cell phones and so forth, have parts that were at some point in their life liquid. And in the forming processes, surface tension is very important. And so this device actually depends on surface tension. And so the device is the switchable electronically controlled adhesion device. And it's a device that is lightweight, can adhere, grab and release to whatever you want, a blackboard, a ceiling, a piece of tile, roofing material, and so forth. So this demonstrates the adhesion device being brought up to the substrate now. The adhesion device is mobile. We're going to load a cargo onto it to illustrate the cargo capacity, cargo handling capacity of this. Now we replaced the little LEDs just show whether voltage is applied or not. And through most of this, you'll see that there's no voltage being applied, so there's no power to this. It's very uses power very sparingly, and the paper clips are being loaded. You'll be thankful for the time-lapse aspect of this, and you'll see that we reach a cargo of about 30 grams, and then we'll release this. You'll see a quick flash of one of the other LEDs, and the cargo and the device will fall. So this is, again, the take-home message here is the cargo that it can carry and the grab-release and the time scale for the grab-release. So this is a device which is, has a larger footprint than the previous ones. It's also going to have a cargo on it. The power supply is off board. The strips you see are the contacts which allow the power to be brought to it. And the load here is on the order of 60 grams. Now you'll see us release it, and the drops will pull in, the device will release and fall into the hand of my assistant. All these demonstrations follow theoretical predictions that say that if we can downscale even further, that means even make the droplets smaller, that we can achieve adhesions that approach an epoxy-like strength. So we can have a reversible, instantaneously reversible, epoxy-like strength adhesion that turns on and off in a very lightweight platform. Perhaps the most straightforward direct application of what you see in the videos is a pick-and-place type of application that one might use in a factory robotic situation where you're grabbing parts and moving them around. And you want to do it where there's little residue, little adhesive residue, and since these are water droplets, the water evaporation, there's essentially no evidence that they've even been grabbed. And so this might work in a silicon chip fab situation or a large format printing situation where you want to avoid the marks that the rubber grippers and sort of create when one's moving large format paper-like substrates through a device. And there we have the advantage of we know exactly what type of grabbing onto we're going to be doing, and we're going to do this many times over, and so we can basically narrow our design to suit the particular application. Another might be the digital aspect of these droplet switches that go into this adhesion device is that it can switch small volumes And this would allow, for example, pumping of a drug in a very cheap way that is fast and is also very precise because of this digital nature of the switching, the pushing of one droplet out. And finally, perhaps a little more visionary would be to use these devices on something like to make a drone pod. I think the strength of adhesion, and given the fact that you can do this in a very lightweight, with a lightweight technology, that is this electroosmosis, is very important. You don't have, part of this is due to you have no solid moving parts to switch the liquid in and out. It's all done electronically. So all those are kind of key fundamentals which make this a unique combination of concepts and lead to a successful marriage in terms of technology that's coming out of it. What we really would benefit from is help in narrowing the particular direction one would like to go with this technology. And that means choosing between one of the 3 or 4 areas that I mentioned, and then specializing. The manufacturing should not be an issue. These are relatively straightforward to manufacture. Why are we interested in a startup for this? Well, there are a number of possible directions we could take this technology, and we've had a multitude of interests from a variety of companies. I think what it really needs is some understanding of where, a little more direction in where we might go with it in terms of what might be most effective, and we need some expertise in de-risking to get this to a place where it really moves forward. So a startup with somebody with that kind of expertise would be perfect for this startup.